Hello everyone from Learning Academy Foundation. I'm Mr. Andrea Filippo Lombardo, the founder of this educational business for every subject and every class. Today we are going to study computer science about the digital representation of data. Take the material. So we often hear the term digital used, but what does it mean? The data can be represented analogically or digitally. In analog devices, data varies continuously over time. In digital devices, data varies continuously over time using discrete numbers. Let's take an example. We could imagine two ways to overcome a difference in height, an inclined plane and a staircase. The inclined plane is an example of analog, that is, allows us to use the step we want. The staircase is an example of digital. There is no half step. The binary system is a positional system. The decimal system is also positional, only it is base 10 instead of 2. The binary system uses only the digits 0 and 1. They are the coefficients of the power 2. For example, 100101 in binary system is the number 37 in decimal system. In fact, 2 power 5 times 1 plus 2 power 4 times 0 plus 2 cubed times 0 plus 2 squared times 1 plus 2 power 0 times 1 is equal to 37. You can use a method to convert decimal numbers to binaries, such as the remainder method. Let's see an example. 119. I want to see how much is 119 in binary number. Binary system. 119 divided by 2 is 59, remainder 1. 59 divided by 2 is 29, remainder 1. 29 divided by 2 is 14, remainder 1. 14 divided by 2 is 7, remainder 0. 7 divided by 2 is 3, remainder 1. 3 divided by 2 is 1, remainder 1. 1 divided by 2 is 0, remainder 1. By inverting the series of remainders, in other words, by writing them from the bottom up, the number 1110111 is obtained. So 119 in decimal is 1110111 in binary. The question is, why does the computer use zeros and ones? The computer is made up of devices that can only assume two different states: on, in other words, 1, off, that is 0. The devices in question are the transistors, fundamental component of the microprocessor chip. From these zeros and ones, called bits, a computer can build any number, as long as it has enough transistors grouped together to hold the ones and the zeros themselves. Similar principle governs data storage. A portion of a magnetic disk can be magnetized, that is 1, or not, that is 0. The surface of a CD-ROM may be intact, that is 1, or not, that is 0. Bit derives from the English binary digit. Typically, the computer uses groups of 8 bits to represent a number, letter, or symbol. The alphanumeric character set is called the American Standard Code for Information Interchange, ASCII character set. Each character is uniquely encoded. A group of 8 bits is called a byte. 8 bits can represent 256 different values. Computers generally use a byte or a series of bytes to represent information. 16 bits will represent 256 times 256. It is 65,536 different values. 24 bits will represent 256 cubed. It is 16,770,000 7,216 different values. The ASHI, American Standard Code for Information Interchange coding scheme, conceived in 1965 by Robert Bremer and approved in 1968 by ANSI, includes 256 combinations divided into two subgroups of 128 each, respectively called standard and extended. They contain all possible combinations of 7 and 8 bits respectively. 8 bits form 1 byte. The standard ASCII, called also ASCII, that uses 7 bits per code and can represent 128 characters, numbered from 0 to 127 in the hexadecimal numerical system, from 00 to 7F. The extended ASCII uses 8 bits per code and can represent 128 characters, number from 128 to 255 in the hexadecimal number system, from 80 to FF. In the standard ASCII set, the first 32 codes are assigned to communication or printer control characters and are used in data transmission between computers or between computer and printer. The remaining 96 codes are assigned to punctuation marks, digits 0 to 9, and the letters of the Latin alphabet, uppercase and lowercase. This is a useful table for comparison between the various multiples of the byte. So kilobyte is abbreviated as K or KB. There are 2 power 10 number of bytes approximately, and so number of bytes are 1024. Megabyte, abbreviated M or MB, there are 2 power 20 number of bytes approximately, so about 1 million bytes. Gigabyte, abbreviated as G or GP, there are 2 power 40 number of bytes approximately, so about 1 billion bytes. Terabyte, T or TB, there are 2 power 80 number of 2 power 80 bytes approximately, so about 1 trillion bytes. For today is everything, and thank you for your attention. I wish you have enjoyed the lesson, and I wish it's useful for you, for your subject. And you can put out like a thumb up, like for me, thank you. And you can also subscribe my the channel so that you don't lose any further video that will follow. Next time we will still continue about information technology, computer science. Okay, and you can also follow Learning Academy Foundation in Instagram and on Facebook. You will find the links below in description. Thank you for your attention again. See you next time. Bye.